Let's look at section 6.4 of chapter 6, pairs of angles. We'll start with example 1. In figure 6.9, or in the adjoint figure, lines P, Q and R, S intersect each other at point O if angle POR, which is this one, has a ratio with ROQ. ROQ is this one, is 5:7. Find all the angles. So we know that PQ and RS are angles, which means that angle POR, which is, let's say, angle 1, plus angle ROQ, which is angle 2, total to 180 degrees. This is via an axiom, right? That they are linear pair of angles and ray OR falls on PQ. Therefore, angle 1 and angle 2 total up to 180 degrees. We also know that 1:2 is 5:7, which means 5x plus 7x is equal to 180 degrees. So when we find the value of x, we get 180 degrees divided by 12, which is equal to, so this is 630, and therefore 15 degrees. Okay, therefore angle 1, which is POR, is equal to 5 multiplied by 15 degrees, therefore 75 degrees, and angle ROQ, which is 7 of x, is equal to 7 multiplied by 15 degrees, which is 105 degrees. Now how about the other angles? Let's say angle 3 and angle 4. So angle, see, vertically opposite angles are equal when there are two lines that intersect each other. Therefore, angle 3, or let's say angle QOS, is equal to angle 1. Therefore, it is 75 degrees. And angle SOP is equal to angle ROQ, which is 105 degrees. So we have the value of all four angles in the question. So in example 2 of pairs of angles, this is an interesting question. See, it says that ray OS stands on a line POQ, right? So you have POQ line and ray OS stands on it. Ray OR and ray OT are angle bisectors of POS and SOQ. And it's also saying that, hey, if POS angle is equal to x, so angle POS is equal to x, you have to find angle ROT. Now, so if POS is equal to x, then angle ROS is equal to x by 2, right? And what is ROT? It's essentially angle ROS plus angle SOT. So your value of ROS is known, x by 2, right? Now, what is the value of SOT? So using these relations, we can say that, hey, x plus angle SOQ is equal to 180 degrees, right? SOQ is equal to then 180 degrees minus x. Now, OT is angle bisector of SOQ. Therefore, twice of angle SOT is equal to 180 degrees minus x. So, angle SOT is equal to 90 degrees minus x by t. So, we'll put this value here, right? So, it's 90 degrees minus x by 2. So, this x by 2 and this x by 2 cancel out, and hence it's 90 degrees. So, angle ROT is equal to 90 degrees. Now, in this case, the solution we found does not have any variable. But in case question comes wherein, these x by 2 and x by 2 do not cancel out, then it is totally acceptable to write the value of ROT as a function of variable x. You'll arrive at this just by uh, finding the solution or solving the equations that are available to you. So this is how we wrap up example 2. Now let's look at example 3 of pairs of angles. So in figure you have 4 rays OP, OR, OQ and OS, and what it is asking you to do is that, hey, prove that the 4 angles sum up to 360 degrees. So angle POQ, angle QOR, angle SOR and angle POS. So now the only axiom we know regarding sum of a pair of angles is that, hey, if there is a linear pair of angles, right, in such a case, then the angles 1 and 2 sum up to 180 degrees. But here, as we can see, there's no linear, there's no single line. There are 4 rays originating from the same point. So what we'll do is we'll create a line. Okay, so let's say this is ray AOA, and it forms angles POA and angle AOS. Now, based on this, what we can say is that, hey, since AOQ is a line, angle QOP plus angle POA sum up to 180 degrees. Similarly, angle QOR plus angle ROS plus angle SOA is equal to 180 degrees, right? And see, angle POS is basically sum of angle POA plus angle AOS. AOS is same as SOA, right? Therefore, we'll add these two equations. So you have angle QOP plus angle QOR plus angle ROS, and you have these two terms left, okay, which is equal to angle POS. So we've added the left hand sides. Now we'll add right hand sides. 180 degrees plus 180 degrees, you get 360 degrees. So it's a matter of just solving, creating a situation in the given statement that allows us to use the axiom of linear pair of angles. And then we write the two equations based on the axiom and we solve for those two angles such that the angles POA and angle AOS are replaced by angle, the larger angle. Okay, so this is how we solve for example 3.